Welcome to Unit 4, Day 2. We're going to look at direct variation scenarios, which are scenarios where we can look at relationships and see their graphs, their tables, their words, and their equations like we looked at last day, were introduced to last day. All right, so what we're going to do is we're going to look at a scenario here. We're going to do this example together, and I'm going to fill out all the information, and then I'm going to share with you this file, and you're going to complete 2 of these on your own. Okay, so pay close attention to how I fill it out so that you can fill out the next 2. All right, the scenario we're going to look at and do together is overhead markers come in packages of 5. That means the number of markers you have depends on the number of packages you buy. So we're going to graph this relationship. We're going to write a table and all this, describe it. But first, let's start with a table. That's a great place to start with the idea. Okay, and we have to decide what the independent and dependent variable is. This sentence really helps us out here. The number of markers you have depends on the number of packages. So that means markers depend on something else. So we're going to go here and write number of markers. And that means the independent variable then is the number of packages. Okay. The number of markers depends on the number of packages. So we start with packages and we'll find out how many markers we have from there. Okay, and we're going to make just a quick little table of values here. We're going to start always with 0 as a good place to start, and then we'll just do 1 and 2 and 3. Okay, so 0 packages to 1, 2, 3. You can do that for your scenarios as well. If you buy 0 packages, then obviously you're going to have 0 markers. 1 package, you'll have 5 markers according to this description. 2 packages, we're going to get 10, and 3 will have 15. Okay. When we do this table, we are going to calculate the first differences just like we did before. So the first difference from 0 to 5, the difference 5 minus 0 is 5. From 5 to 10, let's jump 5, jump 5, jump 5. So we'll come over to this box and type in that the first differences are 5. And since the first differences are 5 and they're all the 5, we know we've got a linear relationship. All right, we're going to graph this, and we're going to use these 4 dots I've provided up here as the things that you can graph, so you don't need to stress about it. So our first dot is going to go to 0, 0, so we're just going to click and drag it and put it at 0, 0. Okay, and then we'll grab the next one. The next one's going to be 1 package and 5 markers, so 1 package and 5 markers. We actually should change our titles here before I forget. So our independent variable was the number of packages, and our dependent variable is number of markers. Okay, so there we go. So 0 and 0, 1 package means 5 markers. Next one, 2 packages goes to 10 markers, and 3 packages go to 15, and we've got this linear relationship. Once we graph it, I want you to decide which of these arrows or these lines are you going to use to describe this. And then this is where you're going to have to decide, is this a continuous relationship or a discrete relationship? So continuous means we could consider in between these points. So between 0 and 1 and between 1 and 2. Is it possible in this scenario to have half a package? Well, I don't think so. Okay, you can't buy 1.5 packages. You're not going to end up with 7 markers. You're either going to have 5 markers or 10 markers. Okay, so because of that, I think this is discrete. So I'm going to choose this arrow, and I'll put the tail here at the beginning, and then just grab this little blue spot, and you can change the length of this. And looks like my dots are a little bit off, but it's not bad. Maybe bring that dot there just down a little bit. Oop. I think it's good enough there. I don't want you to stress too much about that, like I am. I think that's pretty good. All right, so there is our graph going from 0 to 1 to 2 to 3. Okay? All right, so again, we'll have to decide if your scenario is discrete or continuous. All right, and now we'll decide which area you're going to choose. Next, let's describe this in words. All right, so in words, we can say that the number of markers is 5 times the number of packages. So the number of markers is 5 times the number of packages. That's going to be helpful when we come down and do the equation too. So an equation to represent this, then the number of markers, let's let that be an M, and we'll say equals, and you're going to, if it's 5, the markers is 5 times the number of packages. You see here we got M is equals 5 times the number of packages would be 5P. Okay? And that describes that relationship. All right, so we've got it drawn in a table where the first differences are 5, this graph, words, and the equation. Now let's remind ourselves of the descriptions from last unit. So because this one has a first differences of 5, it goes up. I'm going to say that this is linear because, and I'm going to put B/C, because the first differences are the same. That is the reason why we're going to have these first differences at all. Okay? Next, we're going to decide, is this a positive or negative correlation? So I think it's pretty safe to say this is a positive correlation. It's going up. So it's positive because, again, B/C, because as the number of packages increases, so does the number of markers. As the number of packages increase, as this increases, so does the markers. So it's increasing, which means it's positive. Next, is it discrete or continuous? So this one is discrete. We already had this conversation because you can't buy half a package. Okay, so that's why we chose to do the dotted line as opposed to the continuous solid line. And then finally, is it indirect or direct? Well, indirect would suggest there's a flat rate and would start up here. Direct means it's right here. So direct because 0 packages means 0 markers. Okay, indirect would be there'd be some sort of flat rate like the fare scenario, right? Where even though you ride no rides, you still increase. Okay, so we've done a table. We use those dots to make our graph. We chose either a solid line if it's continuous, a dashed line if it's discrete. Figured out our first differences, described it in words. The number of markers is 5 times the number of packages, and an equation. And then we decided, is it linear or nonlinear? And give a reason. Positive or negative? Give a reason. Discrete or continuous? Give a reason. And direct or indirect. So I'm going to give you this full template solved in your scenario, and you're going to go off and try these other 2 scenarios. And you can fill them right in on the Google slide, and you'll be submitting that to me. Once you're done all these, there's a small little summary video that I'm going to ask you to watch after you do this, okay? So we're not going to pause or anything like that. I'm going to make a separate small little summary video of what we learned in this activity. All right, so you can go and click on the Google slide and you'll get your own copy to do scenario 1 and scenario 2. Good luck.